Shalom everybody. So far so good. So apparently it's pretty popular for people to watch people putting electronics together. I don't know why, but this is something I really enjoy doing. It's a form of stress relief. I love doing it. I love doing it. If I could make a living at this, I would. And I've looked for jobs. No luck though. But I'm going to show you me putting this together today. It's from Radio Shack. It's Build It Color Organ. I thought it was pretty cool. I try to get things that might have a practical purpose. I don't want to get one of those stupid Christmas tree light things. Something that's kind of cool. It actually has a purpose. Like I built the amplifiers and universal remotes, and I picked this one out because it was the one that had the most parts. So more fun for the money. I'm putting my earphones in so I can listen to music, because I know some people don't like background music, but I'll try to talk you through it, give you any tips and tricks, anything like that I know that maybe somebody else doesn't know, and hopefully you guys enjoy this. Okay, so got all my parts out. My solder iron is warmed up. I have the schematic. Which on these, usually it's already all shown on the board. You have like R1 through however many resistors there are, like there's R5. So you don't even really have to know how to read the schematic. So if that's something you're worried about, you don't have to worry about it. All you need to know is R stands for resistor, C stands for capacitor, Q stands for transistor. There's U1 through 5 on this. Those are ICs, integrated circuits, computer chips. These things right here. J1, so those are your jacks, like what you would plug in. So you got a power jack and a headphone jack input, I'm guessing, so there's no microphone. I haven't looked at all the parts yet. Yes. So R stands for resistor. I like to start with the smallest component, or the most low profile component. So you got your resistors, but when they're on the board, they're only going to be about that high, as high as the part is. The reason I like to do that is if I get them all on the board, I can turn it upside down, solder all the leads, and then move on to the next biggest component. And that's nice because if I do like a really tall component like these LEDs and they're sticking up like 2 inches off the board, if I try to go and do a resistor next and I flip over the board isn't going to be as level. It's going to be kind of up and the resistor might fall out. Now some people like to bend the leads over. That's alright, I kind of do that, but I like making it as flush and straight as possible. It's just a personal preference. You will have to look in your schematic or your book. So you have all these different numbers for resistors. So you have to figure out which resistor goes with what number. So on here, you have the 1 resistor, quarter watt. So I'll just look at it. 1 It doesn't even tell you the value, but you don't need to know the value. So you just look at the color code, in this case, brown, black, red. What is that, like 10,000? I don't know the color codes. I usually just use my multimeter. And it tells you the position, so you have R2 through 32, various numbers. So you would just find that color and then you put it in that spot. So I'm going to put all my components other than the resistors aside, and we'll get started. Some other component codes you'll see are D for diode. That's all I can think of at the moment, actually. Parts you're going to need are tools, soldering iron, obviously, some kind of side cutter, or these nippers. That's what I call them, nippers. They're just like side cutters, but they're not actually from the side, they're from the top down. Some solder. I like really small solder. See the stuff, it's really, really thin. I feel like it gives me better control over how much solder I use, and I don't use too much or too little solder. Melts faster, so there's less chance of damaging the part. That can be a problem if you're using like transistors or anything like that. Okay. So start with brown, black, red. This is a pretty good kit. All the bags tell you, they don't tell you the value, but they tell you like R2 and all the numbers, so in this case you wouldn't even need the book. This is assuming that it's correct, but I don't have any reason to believe that it isn't. They're usually pretty accurate. Apologize for the lighting situation and camera. This is kind of the best I can do at the moment. I've never really had a good camera. Another thing you might want is cleaner. I have chemical cleaner and copper shavings. I don't know what kind of metal it is. You just dip your tip down into it. Okay, R2. So just find R2. Man, that's nice. It's already at the perfect width. You just stick it in there. I don't know how they can make it any nicer. This was $20, I believe. Just drop my hook. Cleanliness is very important in soldering. If your parts or components, tools aren't clean, you'll get what's called a cold joint, where basically it looks like the solder melts, but it's a weak join, and eventually it'll break. What you're looking for is nice and shiny. Run a solder, usually not too much, not too little. Kind of, you see how it's got a little fillet, or like a ramp, I guess you could call it. It's just something you get kind of used to as you go. And to solder, you can watch other videos, but just real basic, real quick. you want to touch the lead of your soldering iron to both the pad and the lead of the component at the same time, and then you want to put your solder on the other side and let it flow. If it's kind of slow at first, I like to tin the tip by just quickly touching the tip of the soldering iron to melt it, and then that'll turn a little bit of the solder to the molten state, and that gives it more surface area, I guess you could say, and it just gives more conductivity for the heat transfer, and it works out a lot better. And you can do all the components at once, or in groups, or personally, and I don't know why it's slower, I guess I just like enjoying it. I like doing them one at a time. So I might not do the entire video or the entire board. Probably be like 3 hours long. So I'll do a couple components and then maybe show you the finished product. There's one resistor so far. Where is it? Well, it's not focusing. I'll do a few more for you. Next one is R3. And I think the hardest part of this is finding out where they are. There's so many components that you're hunting and searching. What's the next one? R4. I think I'll just go on to R4. I know it's the same one. Just narrow it down. I'll find R3 later. Found R3. It's almost too tight. It's nice once you get it in there though. So update for my Shofar Mountain viewers. I am going to be back on the mountain in about a month. It is the 27th of March today, and I expect to be back by Passover. I will be back by Passover, Yah willing, as long as nothing bad happens. but I plan to be back by no later than the 18th. Doesn't really matter actually, it's kind of just whenever I get all my stuff packed up and leave. Really looking forward to getting my cabin finished. Having a nice place to stay. The trailer's alright, but it's a trailer. It's really cool having something you know is yours and you built, and something you can be proud of. And I feel like it's a pretty good accomplishment for someone like me, someone my age. Although it's not a very big house, it is a house. It's mine. I built it. I own it. You know? Well, that's 20 minutes, about 20 minutes, so I'm going to shut the video off and then start recording a little later. I'll give you updates on it. I won't do the whole board. So here's all the resistors done. How long that took? Maybe an hour. I did most of them one by one. Next component. So the next shortest component that I'm going to put on are the ICs. These are LM324N. What are those? Comparators? I don't remember. So 4 of them. There, 1, 2, 3, 14 pin. On the board, you're going to have a mark. See that right there, that divot? That means that's pin 1. And it's kind of similar on the chip. So this is pin 1. Alright, time to solder those. Here's ICs in. Just 4 of them. Okay, I put on the ceramic capacitors, which are these brownish things, and I'm going on to the electrolytic. The ceramic capacitors, they don't matter which way they go on, they're non-polarized. The electrolytic ones, little can looking ones, they do, and the negative is indicated by the stripe with the negative on it. Focus. It's also the shorter lead, so you look for the sometimes it's got a C, sometimes it doesn't. Just got a plus and minus on this one. Just put the short negative lead in the negative. So electrolytic capacitors in. Okay, let's see if this works with power. I started to try it a while ago and I didn't even have it plugged up. Luckily, I have a 12-volt source from an old Nintendo. Yay. Lights come on. Music's playing and it's not doing anything. Those are hot. I wonder if this is not actually 12 volts. It's 9 volts. Isn't that great? I don't think I have 12 volts supply. Don't know why it matters. Usually these chips have a range. I'll turn this all the way down maybe. The little manual says turn it all the way up. But maybe that is for the 12 volt setting. Maybe it'll make a difference. Still nothing. Volume doesn't make a difference. Those ICs are getting pretty warm, but I hooked them up right, I believe. I hope so, because it's going to be really hard to get those out. Yeah. I don't know. The only thing I can think of is the power supply. That doesn't really make sense because pretty sure the voltage range is like 7 to 15 volts. So 12 or 9 shouldn't really matter that much. Maybe I'm wrong. Try it on my phone just in case. Those don't work either. My phone doesn't work. Well, it didn't end up working. All that happened were the lights came on and stayed on, and the chips got really hot. I did a video, part of a video, showing that, but didn't think it was worth putting on. My power supply is 9 volts and it says it needs 12 volts, which I didn't think would make a difference. Maybe it does, I don't know. I still don't, but I'll try that. If it works, I'll show you guys what it does. I was really kind of hoping it would work. That seems kind of cool. But there it is. Now you know how to do it. Now, next piece is these potentiometers. 10K, 3 legs, and so you just got to make sure the center leg is the center one. Kind of a non-equilateral triangle, so that's how you can tell on these. Sometimes it's a lot more obvious. This one is almost too hard to tell, but you can figure it out. And now for the LEDs and power and headphone jack. Go ahead and do these real time for you. There's potentiometers. So I gotta trim. light emitting diodes, LEDs, indicated by regular diode marks or a D. Also polarity sensitive, and it is I can't really remember. I believe it's the shorter one is the negative. There's also a flat spot on it, which I can't really see with my eyes, so I'm not going to show you on the camera. There's a flat spot on the board, nice enough to give you a circle with a small flat spot on it. That's what you do. Well, it didn't end up working. All that happened were the lights came on and stayed on, and the chips got really hot. I did a video, part of a video, showing that, but didn't think it was worth putting on. My power supply is 9 volts and it says it needs 12 volts, which I didn't think would make a difference. Maybe it does, I don't know. I still don't, but I'll try that. If it works, I'll show you show you guys what it does. I was really kind of hoping it would work. That seems kind of cool. But there it is. Now you know how to do it.